Good morning, hello and welcome to this video. In this video we're going to be talking about structs in the Swift programming language. Finally, 66 videos in and we are talking directly about structs. So this is going to be your crash course into structs. I don't want to spend too much time on it because we can learn more about structs by using them rather than just me talking about them over 5 videos. Okay, so this is going to be our crash course into structs in its entirety. Okay, so structs, as we talked about in the last video, and if you didn't see the last video, structs are value types, which means everything that we use whenever we, let's just make one first of all. So let's just say person here, ID is just going to be let's just say one as a string, and say here, and we say that other person is equal to person. Let's just change the name to be that we can actually be able to change it, so it's a variable. Let's change this to be a variable too, and now we've got person is now person ID name, or ID1 name David, and we're assigning other person to be equal to person as well. And so if we, let's just do it this way, and we'll say person is equal to person dot name, and then the other one is going to be equal to other person dot name, and we run this, and with no surprise we get person David David. Okay, however, if we copy and paste this now and we say person dot name is equal to James, and we run this again, you'll see we get the second output here is person, James and David, because other person is, well, structs are value types, and we've copied. Value types are always passed by a copy, so whenever we assign it to another thing, it's making a complete copy of the whole struct and all of the properties and everything like that. And when we make any changes to the other one, it doesn't affect the other one. There are two individual values, the individual copies of it. All right, so they're always passed by value. And if you haven't seen that video, check out that video as well, because we talk about that for 12 minutes in depth. All right, but I'm not going to harp on about this any further. They are value types. All right, and this is the benefits of them. So as you can see, is we don't actually need to define an initializer with the struct, okay? Because you can see here that it did it for us, right? And we can just do it. And if we add another property to this, and we say surname here, and we come back to our person, and we could use type annotation here and say it's a person, right? And then just use this here and dot syntax here, and we say ID, name, and surname as well. All right, so this is basically how we could do it, or we could just say person here. So it's a really cool thing. If you use type annotation, then you just have to use the dot init, which is a little bit cleaner sometimes. Otherwise you can remove the type annotation and then just use the struct name itself. Okay, as previously said in the beginning of the video, structs are value types, so we never pass them by reference, which means that we always make a copy when we change something. Now, structs can also have methods. Methods are not functions. Functions are not methods. They add functionality to a structure, a person, right? So we define a method on a struct with the func keywords, all right? But they are not functions, they are methods. And here we could say get full name, and that's going to return a string. Whoops, a string. And here we could then just say name followed by surname. And as we know, we don't have to say the return keyword because we don't have to. It's only one expression, so it's going to return that. And then down here we could then say let's just say here person get full name, and other person get full name. Let's remove that, and let's copy this down here instead, and we run this. You'll see you get exactly the same output. All right, and obviously because person down the bottom doesn't actually have a name or an ID, so let's actually give it a name, shall we? There's a bit of a mistake. and we run this once again, you'll see something different. You see person David Thorne, because the person and the other person both have the same values. And then the second one is James Thorne and David Thorne here. So this is now introducing you to methods. However, we don't actually have to use a method for this. What we can use is something called computed properties, and they are always vars. Okay, you cannot do this with let. You can only do this with var. And what we're going to say is we're going to say full name. Rather than having a property, a function, we're just going to have a property instead. And we're going to copy and paste this as well. So now you can see that we've got a get full name method that returns a string, or we can have the full name here instead. So if we now just say full name here and we run this again, you'll see we get exactly the same thing. So we don't actually necessarily have to write functions in struct if you don't need any parameters. All right, if it doesn't need any parameters, then use a computed property in itself. This is the other thing. If you do want to have parameters in the function, then you can add parameters as per any other function would, and so on. So the methods are exactly the same as functions, but methods are always within inside of a structure, and so on. Whereas functions, they're not inside of a structure. All right. So now the other thing is that if we wanted to say, for example, update name, and then we just say here name, and let's just say new name here instead. And now we can say self name is equal to new name. We don't actually have to say self. We could just say name right here. And now you can see here, cannot assign to property self is immutable. All right. And what this is saying is because structs are value types already, you cannot mutate, you cannot change, you cannot modify a value type because it doesn't have you cannot update a value type. All right, but in order to update this value type, we have to add it here with another keyword, mutating. Right, we have to add another keyword here to say, hey, this function can update itself. All right, so now if we get rid of all of this and we say person update name, we can then say James here, right? And just trust me when I say this, and we say person dot get full name, and we print this out again. You can see James. Let's change this to a capital J just to show you that it's here. And then if we print out the other, whoops, what am I doing? So if we just print out the person get full name, and then just for the sake of showing you on other person get full name, and we run this once again, you can see James Thorne, David Thorne. Okay, well, I think you've got the point now here with the value types is that whenever we assign it to another variable, it assigns all of the properties inside of it by a copy rather than by a reference, which we'll get to in other videos. So now we can update the actual struct itself. However, if we change this person to be a let, you can see cannot use mutating member on immutable value. Person is a let. So even though this one person struct has a mutating function that can update itself, it still has to abide by that the actual variable itself has to also be able to be mutated, to be changed. So this is something that really makes sure that when you pass something to another function, it cannot have any side effects. Okay, and what do I mean by this? So if we have a function and we say change person's name, all right, and we're going to take a person, and it's going to be a person, and we'll say new name is then going to be this, and this is then going to return a person. All right. So what we're going to do is we're going to make a copy of the person. First of all, remember it's passed by value, and structs are value types. So whenever we call a function with a struct, it's always passed by value type. And we're then going to say then person, and then we're going to say person update name with then the new name, and then we're going to return the other person. All right, and when we use this, we're going to say new person here is equal to change person, right? And then we're going to say person, and then we're going to say in here Steve. All right, and then we'll print out person dot get full name, and then we'll print out new person get full name to show you where the difference is. And as you can see, person has kept David Thorne, whereas the new person has then a different property in itself. Okay, so whenever you call a function, and you pass a struct as an argument, it's always passed by value, and that's why structs are value types. All right, but if we hadn't have done this underscore person here to convert it to a variable, it was immutable. We couldn't change it. So even though we can call this update name on the struct itself, when we passed person here, this was passed as a copy. All right, so inside of it, this is a copy, and I want you to really understand this. Inside the code block here, in the body of change person name, this person is a copy. So this person and this person are not the same. They just have the same content. All right, but they are a copy, and then we copy it to this to make it immutable, and then we update that one person, and then we return that one person. And when this one this function ends, it means that this person here is gone in the memory, right? This one person is returned, and now it is set to this one new person. So it is being assigned to this one new person. Okay, and these are all going to become pertinent in the future when we talk about other things, which we talked about enclosures, and we talked about capturing, and we talked about scope, and so on. This is going to become really, really pertinent in the future. So this is why I'm trying to go over this as much as possible. So now that you've seen that we can create structs and they have their own initializer, we don't have to create the initializer, but Xcode does it really well for us. As you can see here, we can just say init, and it will initialize everything in its one order. Now we can have default properties as well, so we could just put like Thorn here instead, and then just run this once again. And so as you can see here, it doesn't care about Thorn because it's a let property anyway. All right, and if we change it to a var, and we just run this once again, and as you can see here, it still has surname there too, but we could put a default value here also, which would seem a little bit redundant in giving surname a default property as well, because we are updating it inside of the init, inside of the constructor. And as you can see, we reference the person explicitly using self here. Now we're using self here because the parameter name has the same name as the actual property. So we are saying, hey, I want you to assign the value of this one ID variable to the struct itself. Now you can't access any other functionality inside of the struct itself, as in you can't access it until it's been initialized properly, okay? But that's something that we'll talk about in later videos. With that said, there are some other things that we could do, but we haven't been over these things yet, so that's why I'm going to leave it. But if you have seen like other declarations after the person, if we just go to show you string, you can see actually it was integer, I think it was. Anyway, you see some declarations here like case iterable or something like that. These are protocols, but we'll get into them at a later stage, I promise you. Other than that, I hope I've introduced you enough now to structures and that they are value types. So this is the most thing I want you to understand from this and have it hard coded in your head. Structures are value types. Every single time you assign a variable with a structure, it is a value type, and when you pass it to a function or to another variable, it is always going to be copied. There's always going to be a copy of it, and whenever you mutate that one, it needs to be a variable, and functions can be mutating as long as they are identified with the mutating keyword and so on. And yeah, this is basically structures, but we are going to be using them everywhere in the up and coming videos. It's probably going to be used in every single video in the future. Okay, with that said, value types have an opposite, and if you're interested in knowing what the opposite of a value type is, I'll see you in the next video. With that said, don't forget to like, subscribe, share, and do all of the other social media things that you could do. And if you do have any questions, feedback, concerns, etc., then let's start a conversation in the comments section down below. Now, obviously, the other videos are going to be coming, so we're going to go into more detail about the other things coming up. So just have a little bit of patience. If those other videos haven't been released yet, have a little bit of patience, because I will be making those videos. So before you ask me the question, I'm just going to say to you, refer to the future videos. Thank you very much. I'll see you in the next video. Ciao, ciao, and goodbye.